Hello. Woo. All right. Welcome, welcome. My name is Banjo Biyami. I'm a developer advocate at AWS.
Hello, everyone. My name is James Yi. I'm the senior SA and specialized in AI ML.
And today we're going to talk about building a product review classifier with transfer learning. So first, we're going to go over the solution agenda, how we prepare data, model training, model evaluation, and then deploying a model. First, solution overview. So here has an AWS Deep Racer. Couple folks, yeah. So if you go to Amazon.com and you look at the reviews under Deep Racer, you're going to see people leave great comments on how easy it is to use and how fun it was to learn reinforcement learning in the Deep Racer. And then people are going to see this little box at the bottom, like say, 7 people found this helpful. So a human actually said, OK, I think this is helpful. This is going to be helpful to somebody else that's looking to purchase a Deep Racer. But at scale, how can we classify helpful reviews? We can't have every person manually say this review is helpful, this review is not helpful, especially with all the things on Amazon.com and other things. We need to make some way to automate that. So this is where natural language processing comes in view. This talk is going to walk through an example of how we can build an actual end-to-end model, how we can train that model, use a framework called Hugging Face to help train that model, and then deploy it using AWS SageMaker. So Hugging Face Transformers, it's a way that allows you to download and train state-of-the-art pre-trained models without having to train your own model. It reduces your compute cost because you're leveraging already trained models on a task. It reduces your carbon footprint because you don't need to start from scratch. You're already using models that have been trained for you. And it saves time from training by using transfer learning, by leveraging the models that have already been built for that specific task. It's useful for things such as question answering, image recognition, listening to audio, and a multimodal, such as DALL-E Mini, sending text and generating an image. Hugging Face Transformers can power all of these use cases. So before we get started with any model training, we need to collect data. Using the AWS Data Exchange, you can find data sets for over 300 different tasks, such as satellite images or text-based data sets. For this, we're going to use a helpful sentences from reviews data set that's on the open data of AWS Data Exchange. It provides 2 files, a training JSON and a test JSON, typical machine learning classification task. And it's very, very basic. It's in this pseudo JSON format. It just has the sentence, the helpful score, the image, the text. As a true builder, I'm going to automate this. So I have a code that can just grab the raw data, transform it. I want to turn it to a data frame for using pandas that make it useful for machine learning. So the first thing I do, I actually get the data, simple get request, get the data. But the data is in this weird format of JSON. So I have to split, make it to a single array where I can just iterate through these, and then I want to transform this to a CSV that's usable for machine learning. It's my next task. To make this into a classification problem, I just want the label. Is this review helpful or not helpful? The data that's provided in the data set came in a numeric score. So it had 1.7 as helpful, like 0.3 is not helpful. So I just made a simple function that can just transform. If it's greater than 1, that's helpful. Less than 1, not helpful. When I run through the code, I have a nice, simple CSV that just has the text of the review and then the helpful score, yes or no. Once I have the data, I want to begin training my model. So there are many different machine learning frameworks. So there's TensorFlow, there's PyTorch, sklearn, Spacy. All of these things are useful for building machine learning models, but it's a harder developer experience if I really want to just get started quickly and I don't want to learn a bunch of things, go through a lot of documentation. The task is not clear how I would utilize these frameworks to make a very simple classifier. if there's one thing you remember from this talk, Hugging Face provides a developer-first experience to build and train deploy machine learning models. Hugging Face leverages TensorFlow and PyTorch underneath the hood, so it makes it very easy for someone who doesn't have much machine learning experiences to easily build upon pre-trained models and be able to do a classification task relatively simply. So I'll walk through some of the code here. We import a bunch of the transformers code. We actually can load the data set. Once we have that data set, we can run it through the model training pipeline. One of the big advantages of using Hugging Face is we can leverage pre-trained models. I don't want to have to train a model for this task from scratch. So I'm leveraging a BERT model, which is a state-of-the-art model for natural language processing task. And with that, I can retraining a pre-trained model on a data-specific to your task is known as transfer learning. So for this, I'm leveraging the pre-trained model of BERT. I'm using my data set that I just created, and I'm going to be able to make a model that can predict if something is helpful or not helpful. So I can run this code locally on my own machine. I can define the metrics I want to look at. I can train a transfer argument, and I can just set up the training job and then run train. A good thing about running on my local machine, I will be able to generate checkpoints every how many epochs. So in this example, I'm creating a model. Every 500 epochs, I'm saving the output of model so I can test it at different times. And it's very easy to just set this up on my local machine, but it takes a lot of time. So I'm doing a lot of data, it's a lot of processing. My laptop's start getting overheated. So I don't want to be able to, if I had a lot of data set, this wouldn't be really viable to do on my local machine. This is where we're going to leverage the power of the cloud.
Yeah, now let's take a look which kind of benefit that actually we can get from Amazon SageMaker to train your model. Yeah, I mean, Amazon SageMaker can automatically tune your model parameters by adjusting thousands of combinations of algorithm parameters. And then you can easily reach the best predictions that your model is capable of. So on top of that, we have Amazon SageMaker Experiment, which can managing and track those training jobs. And on top of that, we also have Amazon SageMaker Debug. So it can be used to monitor the metrics and also profile the training jobs in the real time. So in that sense, users can easily correct the performance errors whenever you see anomaly in your in the training metrics, and it will send notification to the users. And another feature for SageMaker Debugger is it can also automatically stop the training jobs whenever the preferred accuracy has reached. That means you actually can save a lot of training time and also cost. And we also have Amazon SageMaker distributed training, right? So it can distribute large machine learning models and also large data sets across multiple GPU instances, and which also can speed up training a lot faster. And yeah, I will also dive deep a little bit in the next slides. Previous one. Yeah. And well, you can also speed up your training by using just training compiler. You can just turn on the option, and it will speed up the training up to 50% through graph and also kernel level optimizations. So it can enable users easily, to best use GPU more efficiently. And last but not least, we also have Amazon SageMaker Managed Spot Training, which can save up to 90% of your saving cost. Yeah. Next. Yeah, let's now dive deep a little bit in the distributed training. So in most recent years, we really see rapid development in the field of natural language processing, right? More and more sophisticated large language models were built one after another. And a couple of examples. We have Elmo, which have 94 million parameters. And then we have a BERT large, have 340 million parameters. And then we have a GPT-2 coming out with a 1.5 billion parameters. And then now we have a GPT-3, which contains 175 billion parameters. Those large language models really can consume tens, even hundreds of gigabytes of memory, right? Which cannot easily put in the memory of a single GPU instance. So to really overcome the limitation associated with training the model in the single GPU, we actually developed a model parallelism. So in that sense, we actually can distribute models across GPU instances. And there are two options, actually. One, we call it pipeline model parallelism. In that sense, like a single layer or maybe multiple layer will be trained in a single GPU instance. We also call it like a vertical parallelism. And the other option is called a tensor parallelism. In that sense, a single tensor will be partitioned into different shards, and each shard will separately trained, processed in the single GPU. Yeah, with those options, we really can make training large language model impossible to possible. And also, with the growth of large language model, we also see the data set, actually training data set also grow tremendously. And the machine learning practitioner has to spend a lot of long training time to train these data sets. And one example, right? If you train the BERT large using even like P3DN instance with like 8 NVIDIA GPU instances, it could take over 100 hours. So at that moment, we can actually use a data parallelism. It actually distributes the data into different GPU instances. So each GPU instance only trains the partition of the training data set. So in that sense, it can also speed up the training quite a lot. So I'm not going to dive deep into more detail, but I provided the link for the SageMaker developer guide. So you can get more technical details and also even example code. So you don't have to start up from scratch.
Yes, I won't be running that on my local machine. So once we finish training a model, we can actually then evaluate it. With Hugging Face, they actually provide a framework that allows you to leverage dozens of popular metrics to evaluate your model. You can have comparisons of measurements, community-built metrics. So for example, in this code up here, I'm looking at the F1 score, I'm looking at accuracy, and I can add that directly to my model training pipeline so I can see as the model is evaluating what those scores are going to be. When the model is done, I can evaluate that to see how well my model performed against the test data set. And we have talked about debugging and profiling runs. You can actually leverage that and provide real-time graphs to see how your model is doing during the training, so you can course correct if something's not right, change the data set. But having this visibility allows you to know what your model is doing, and you don't have to wait to the end of training to actually see a result. So we talked about training and evaluating the model, but how do we actually deploy this model and get it to a production and API endpoint that people can actually use it? So before I make an API, I like to test locally. With Hugging Face, the code up here allows you to easily just import your model and then put in some example text and get a result. In this example, we have the result. It's not helpful. The text is, "This is a Christmas gift for my grandson." That's not a helpful comment, so the model flags that it's not helpful. With Hugging Face Hub, you could actually upload your model directly to Hugging Face so the community can leverage it. Think of it almost as a GitHub repo where I can just git out install, git clone, push my model code, git add, and then push it up, and then I have all my files up there for the community to leverage my model. From the Hugging Face Hub, you can actually look at metrics of your model. You can have an example API where you can even put text, press compute, and you can get a result back. You can see how many people have downloaded it. You can put details about your model. So it's really a community-driven way of like showcasing your model and letting other developers leverage them and build on top of that. And from Hugging Face Hub, there's actually a deploy button. So by clicking that deploy button, I actually have the opportunity to deploy this directly to AWS SageMaker. It provides the sample code that I'm going to need to use and put that in my SageMaker notebook and have that be deployed as an API endpoint. The code allows me to actually identify train the model, make a SageMaker endpoint inference point. I can then put the data of what I want to send, and I can actually use BOA304 to make a Lambda API endpoint where I can just send that client, the BOA client, I can get my SageMaker endpoint name, pass in the data, and get a result back. And I can put this in a Lambda function to make it a serverless API. It's leveraging the SageMaker inference endpoint that was built via the code that was deployed, and then we can just pass in data and then have that API be able to return predictions for us.
Yeah, now let's take a look multiple benefits actually we can use SageMaker for the machine learning model deployment. There is no single deployment method actually can fit all business use cases, right? So in the last 18 months, actually, Amazon SageMaker tried very hard and doubled the number of the inference options. Currently, there are in total 4 inference options for the model deployment. Let's go through them one by one. So we have real-time inference. This is one of the most popular used for the machine learning models. Yeah. So it is ideal for the workload that require real-time, sub-second low latency, and interactive workloads, right? So, and it also have the adjustable auto-scaling capacity. And meanwhile, it also supports both GPU and also CPUs. And it also can support multimodal endpoints, which is ideal for the A/B testing. And the second one is a batch transform. Yeah, sometimes for the machine learning model deployment, the data set is not coming in just one time. We have like large batches of data. So, but in that condition, we don't need to, there's no like real-time kind of requirement, right? So in that condition, we don't need a persistent endpoint to kind of running all the time. And so in that condition, we can easily actually set up batch transfer jobs to make the machine learning model predictions. And it can save a lot of cost as well. The third one is also new capacity for the SageMaker. It's called asynchronous inference, which actually take all queues, incoming requests, and also process them asynchronously. It is ideal for the workloads with the large payloads, up to like 1 gigabyte, and also large timeouts, and near real-time requirements. And asynchronous inference can also save cost by auto-scaling the number of inference to 0 when there is no any incoming request. Right? It can also save a lot of cost. And the last one is our newest inference option called serverless inference. It was introduced in last year's reInvent and became generally available in April of this year. And serverless inference really allows machine learning practitioners to do the model deployment easily, like without kind of managing the underlying infrastructure. Like in previous slides, actually, Banjo showed the example, like you can just set up the maximum memory, also maximum concurrency. And the Amazon SageMaker will provision and scaling, and also turn off the instances. So in that sense, actually users only charge for the time that's actually running the code and also the amount of the data that's being processed. So if you want to dive deep a little bit more, actually there is another Chalk Talk session tomorrow, 11:45. Actually, we have a SageMaker expert will introduce how you can train and deploy large language models on SageMaker. Yeah. Back to you.
So to recap, I extracted, transformed, and loaded the data set from the AWS Data Exchange. Getting data is always the hardest part of starting a machine learning project. By leveraging the AWS Data Exchange, you can bootstrap that process and begin training a model immediately. For natural language processing task, I'm going to use Hugging Face. It provides a developer-first environment for me to easily use pre-trained model to use transfer learning to help with my task. Hugging Face also provides evaluation metrics, so I can easily evaluate my metrics using community metrics or the standard ones that are available for that specific task. I can upload the model to Hugging Face Hub, which allows me to have the community leverage that. It can also be private if you don't want to share that, and then it can easily deploy to AWS SageMaker with a single button. And then using the SageMaker endpoint, we can have it create an API that can just serve predictions based on what my use case is. Here are some resources if you want to learn more, dive deeper into learning about SageMaker and Hugging Face.